Alright, this is the Omega 1A homework, which is irrational exponents. First problem, we got 3 to the negative 4 times 3 to the 8th. Using the product property, since we're multiplying two things with the same base, we can take the exponents and add them. Negative 4 plus 8 is 4. 3 to the 4th means 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. Number 2, we have 5 to the 3/4, which is in turn raised to the 4th power. We can use the power to a power property here, which says that you take your exponents and you multiply them together. 3/4 times 4, well, the 4's cancel because you're multiplying and dividing by 4, which leaves you with 5 to the 3rd, which means 5 times 5 times 5, which is 125. Number 3, we have 8 to the negative 1/2, which is in turn raised to the negative 2/3. Please keep in mind when you're doing these, there's lots of different orders that you could do these problems and get the same result. So if you did yours differently than mine, and you get the same answer, it's likely that you did it correctly. This, again, is the power to the power rule, which says that you can take the exponents and multiply them together. When multiplying two fractions, you multiply the tops and the bottoms. Likewise, you could cancel something from the top and the bottom if that thing has the same factors as something from the top or the bottom. For example, you can divide both 2 and 2 by 2 and get 1 and 1. Negative 1 times negative 1 is 1. And then 1 times 3 is 3. So we get 8 to the 1/3. 8 to the 1/3 is the cubed root of 8. Which means what number times itself again is 8? Well, that number is 2. Number 4, I'm going to first show you what you cannot do. This is what you cannot do for this problem, but it's what a lot of people do because they misunderstand the properties. The power to a power property combined with the power of a product property, let's say. Some people think that it applies to this, and when they apply it, here's what they do. They say, well, we have an exponent, so we can apply it to both of these exponents. So that's 3 to the negative 1 times negative 1, plus 3 to the negative 2 times negative 1. Once again, this is wrong. Negative 1 times 1 is positive 1. Negative 2 times 1 is positive 2. So then they think, well, that's 3 plus 9, which is 12. This is wrong from the beginning. So let's show you the proper way. Once again, the reason that you couldn't do what just happened here on the left, this is not equal, is because the power to a product property deals with a product. It means multiplication. This is not multiplication, it's addition. So here's how it should be done. In order to use the power to a power property or the power of a product, you can't have addition in the problem. So let's fix that. 3 to the negative 1, to make the exponent change sign to be positive, you reciprocate the 3. So it's 1/3 to the 1st. To make the second 3, to make the second exponent negative 2 positive, reciprocate that 3, it's 1/3, and then the exponent becomes positive. 3 to the 1st is 3. 3 squared is 9. When you add these two fractions, you need common denominators. So you could change the 1/3 to 3/9. 1/9 can stay the same. 3/9 plus 1/9. When you add two fractions, you add the numerators, leave the denominators the same. To make the exponent positive, you take the base, which is 4/9, and you reciprocate it. So it's a 9/4 to the 1st which of course is 9/4. What you see in blue on the right is correct. What you see in red on the left is incorrect. Here is the quotient property. When dividing two things with the same base, 16 and 16, you can write the base one time and take the exponent in the numerator minus the exponent in the denominator. To subtract two fractions, you subtract the numerators, leave the denominators the same. That's assuming, once again, you have like denominators, which we do. 3 minus 1 is 2. 2/4 reduces to 1/2. 16 to the 1/2 is the same thing as the square root of 16, which means what times itself is 16? Well, that's 4. Number 6, we get 27 divided by 27 to the 2/3. This, once again, is the quotient property because you're dividing two things that have the same base. Please note, if there's no exponent for a number, it means the exponent is 1. You write the base one time. Once again, this is the quotient property. Take the numerator's exponent, which is a 1. I won't call them denominators. I'm going to write it as 3/3 minus the denominator's exponent, 2/3, gives us 27 to the 1/3, which means the cubed root of 27. What times itself 3 times is 27? It's 3. 3 times 3 is 9, times 3 more is 27. All right, number 7. The 6th root of b cubed. The directions. Express using rational exponents. Express using rational exponents. Well, you write the base, and then your exponent is the previous exponent as the numerator, and the previous root as the denominator. So that would be 3/6. 3/6 reduces to 1/2. So that would be b to the 1/2. Number 8, supposed to express this using rational exponents. If you have a number like the 125, first see if you know what the cubed root of 125 is. 5 times 5 is 25, times 5 more, that's 125. So the cubed root of 125 is 5. Take the a and write the previous exponent as the numerator in your exponent and the root as your denominator. And then b to the 3/3. 3/3 reduces because 3 divided by 3 is 1. So we get this. Number 9, we got the 4th root of 24 times a to the 12th times b to the 16th. The 4th root of 24. Let's see if 2 works. I'm just going to make a little note. 2 times 2 is 4, times 2 is 8, times 2 is 16. Doesn't work. Maybe 3 works. 3 times 3 is 9, times 3 is 27, times 3 is 81. Doesn't work. That means the 4th root of 24 exists, but it's not an integer. So the best we can do is write 24 to the 1/4, because the exponent for 24 is a 1, times a to the 12/4 times b to the 16/4. Any of your fractions, if they can be reduced, do so. So we get 24 to the 1/4, a cubed, b to the 4th. Number 10, same directions, express using rational exponents. 32 is a number, no variables. If you can find the 5th root of that, then find it. Let's see, maybe it's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means we can take the 5th root of 32 and say that's just 2. X to the 5th, we could say x to the 5th divided by 5. Pardon me, I said that incorrectly. X to the 5/5. And then y to the 8/5. If any fraction reduces, you should reduce it. 5/5 reduces. 8/5 does not reduce. Number 11, the directions are simplify or evaluate. Or perhaps that's not true. The directions are to express using radicals. Well, you're supposed to express using radicals unless you don't need a radical. In other words, if 64 to the 1/6 just becomes an integer, then write that as an integer. What could it possibly be? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this is simply 2. Once again, the directions were express using radicals, but here we don't need to write a radical because it just reduces to 2. Number 12, the directions. Express using radicals. Well, since each denominator in our exponent is a 3, that's going to mean this is the cubed root. So it's going to be 4 to the first, a squared. We've got to be careful about this y to the fourth. If we put a y to the fourth in here, that really means that we have 4 y's we're multiplying together. Well, 3 y's together, if it's a cubed root, the cubed root says what times itself gives you that? Well, y times y times y gives us y cubed. It means you can pull a y out to the outside and leave 1 y on the inside. So this problem up here reduces to a y on the outside and a y on the inside. That's the cubed root of 4 times a squared times y, and that's all times the y that's out in the front. Number 13, the directions express using radicals. Well, what you see in parentheses, r times t squared to the 1/5, using the power of a product property, we could write it as r to the 1/5 times r to the 2/5 times v to the 3/5. Now using the, to change this to radical form, since each denominator in the exponent is a 5, we can say the 5th root, and then r to the first. Oh, I'm sorry, I made a mistake here. This is not an r, it's a t. R to the first, t squared, and then v cubed. That is written using radicals. Number 14, the directions. Express using radicals. Well, let's first simplify it. This is the quotient property. You take the base and apply the exponent from the numerator minus the exponent from the denominator. 2/3 minus 1/3 is 1/3. As a radical, that's the cubed root of x to the first. Number 15, the directions. Express using radicals. Well, at the beginning here, we have the power to a power property, and also the power to a product as well. So we can take the x to the 10th and apply the 1/5 to that, so you multiply the exponents, and the y squared, apply the 1/5 to that, and of course we have the original a to the 2/5. 10 times a fifth is 2. 2 times a fifth is 2/5. And then a to the 2/5 is 2/5. Please note, this a squared does not have any radical. There's no denominator in your exponent, so it stays a squared. Pardon me, not a, x squared. The y and a can be written as 5th roots because their denominators exponents are 5. Y squared, a squared. Number 16, we got the directions to simplify. X to the 6th times x cubed times x squared, that's the product property. You write the base one time and you add the exponents. 6 plus 3 plus 2 is 11. Number 17, we have the power of a product property. So the exponent gets applied to each term, each factor, not each term. There's only one term here. 5 cubed is 5 times 5 times 5. X to the 1/3 to the 3rd would then just be x. 1/3 times 3 is 1. 4 times y to the 4th to the 3/2. This is the power of a product again. So we're going to have 4 to the 3/2 times y to the 4 times 3/2. 4 to the 3/2 we could write as the square root of 4 cubed. And then the next one, 4 times 3/2. 4 times 3 is 12. 12 divided by 2 is 6. Or you could say divide 2 and 4 by 2. You got 2 left. 2 times 3 is 6. Either way, you get y to the 6th. Square root of 4 is 2. 2 cubed is 8. So we get 8y to the 6th. Number 19, the directions are to simplify the problem. Lots of different orders you could do this. I'm going to use the power of a product property, which I've used many times. You take each base with its exponent and you multiply it by the exponent that's on the outside of the parentheses. (1/2) times -4 is -2. -2 times -4 is +8. Multiplying by 4 and dividing by 4 gives us 1. So we got 5 times -1, which is -5. Could write your answer as this. I don't particularly care for negative exponents. So to make the exponents positive, take the base and reciprocate it. A reciprocated would be divided by A. C reciprocated would be dividing by C. Here's another version of the same answer. Number 20 is a doozy, let me tell you. What makes it different than most problems, when you're trying to reduce a fraction using the quotient property, for example, the bases need to be the same. This is a 3, this is a 9. Clearly not the same. A couple different ways you could do this problem. Let's say you want the bases to be the same, and trust me, you do want them to be the same. 9 is pretty easy to change. Let's focus on the 9. Let's say it's 9 to the 30th. How could you write 9 so that it had the same base as a 3? Well, it's 3 squared, of course. 9 is the same as 3 squared. 30 doesn't change. Now we have 3 to the 60th divided by 3 squared to the 30th. Using the power to a power property, 3 squared to the 30th is going to be 3 to the 2 times 30, which is going to be 3 to the 60th divided by 3 to the 60th. Anything divided by itself is 1, with the exception of 0, which you cannot divide by itself. Lovely.